In 1964, a Soviet astronomer asked a question that still haunts scientists today. If an alien civilization exists out there, how will we even recognize it? His answer changed how we think about intelligence in the universe forever. He realized that the one thing every civilization needs, no matter its biology, its culture, or its technology, is energy. And the amount of energy a civilization can harness tells you exactly how powerful it is. He created a scale, 3 levels. And here's the uncomfortable part. Humanity, with all our cities, satellites, and nuclear reactors, doesn't even reach level 1. Today, we're going to find out where we actually stand and what it would take to climb. The astronomer's name was Nikolai Kardashev, and his scale is beautifully simple. Forget spaceships. Forget laser guns. Just measure one thing: energy. A Type 1 civilization controls all the energy available on its home planet. Every ray of sunlight hitting the surface, every storm, every ocean current, all of it harnessed and directed. A Type 2 civilization controls the entire energy output of its home star. That's 10 billion times more than Type 1. And a Type 3 civilization commands the energy of an entire galaxy, hundreds of billions of stars. At that point, you're not a species anymore. You're a force of nature. Each step up isn't an improvement. It's a transformation so extreme that the previous level would look like ants by comparison. So where does humanity rank? Brace yourself. Carl Sagan extended Kardashev's scale into a continuous formula so civilizations could be scored between levels. Plug in humanity's total energy consumption, and we come out at approximately 0.73. We are a Type 0 civilization. We still get most of our energy by burning the compressed remains of ancient plants and animals. From a cosmic perspective, we're a species that just discovered fire and hasn't quite figured out what to do with it. Here's the sobering math. Because the scale is logarithmic, going from 0.73 to 1.0 doesn't mean a 27% increase. It means increasing our energy consumption by roughly a factor of 1,000. Physicist Michio Kaku estimates that we could reach Type 1 status in 1 to 200 years. If we survive that long, and that's not a throwaway line, we'll come back to it. What does a Type 1 civilization actually look like? Start with the obvious. A Type 1 civilization has mastered nuclear fusion, the same process that powers the sun and collects solar energy on a continental scale. Fossil fuels would be a museum exhibit, but the implications go far beyond power plants. With that much energy, you can control the weather, steer hurricanes away from cities, trigger rainfall over droughts. The natural disasters that kill thousands of people today become engineering problems. A Type 1 civilization is also, almost by definition, a planetary civilization. You can't manage Earth's entire energy budget with 200 countries pulling in different directions. It implies planetary coordination, a global grid, a global economy. And here's the twist most people miss. The transition from Type 0 to Type 1 may be the most dangerous period in any civilization's existence. The same technologies that get you there, nuclear power, artificial intelligence, biotechnology, are exactly the technologies that can destroy you. Some scientists believe this is a filter that most civilizations never survive. Now let's go up a level. And this is where things get truly alien. A Type 2 civilization has outgrown its planet entirely. Its energy demands can only be met by its star. And the most famous solution is the Dyson sphere. Physicist Freeman Dyson proposed it in 1960, not a solid shell like in science fiction, but a swarm. Millions upon millions of solar collectors orbiting the star, capturing a huge fraction of its total output. How do you build one? One serious proposal: dismantle Mercury. The planet is rich in metals, has no atmosphere, and sits close to the sun. Self-replicating robots could mine it, build solar collectors, and use the energy from those collectors to build even more. Exponential growth. Some calculations suggest the whole process could take just a few decades. A Type 2 civilization is effectively immortal. Asteroid impact, deflected with ease. Their star dying. They have the energy to move to another one. Nothing short of the laws of physics can threaten them. And here's why this matters for us today. A Dyson swarm would block starlight in a strange, irregular way, which means we could detect one. When astronomers found the bizarre dimming of Tabby's star in 2015, Dyson's sphere speculation went mainstream. The final explanation was likely dust, but the fact that we checked tells you something. We're already scanning the sky for Type 2 civilizations. Type 3 is where human intuition simply breaks down. A Type 3 civilization controls the energy of an entire galaxy, hundreds of billions of stars, harvested simultaneously. Even below light speed, colonizing a galaxy takes a few million years at most. That sounds long, but the universe is nearly 14 billion years old. There's been plenty of time, many times over. At this level, the civilization probably isn't biological anymore. The distances are too vast, the timescales too long. Think self-replicating machines, digital minds, entities that treat black holes as power generators. And this leads to the most disturbing question in all of science. If the universe has had billions of years, if a single Type 3 civilization would leave fingerprints visible across the cosmos, where is everybody? That's the Fermi paradox. Either advanced civilizations are astronomically rare, or something stops them before they get that far. Something we may be approaching ourselves, right now, at level 0.73. The Kardashev scale isn't really about aliens. It's a mirror. It tells us that humanity is standing at the most dangerous doorway in its history, the transition from Type 0 to Type 1. Every technology we need to advance is also a technology that can end us. The civilizations that pass become masters of their planet, then their star, then their galaxy. The ones that fail become silence. So the next time someone tells you humanity has reached the peak of technology, remember, on the only scale the universe cares about, we haven't even reached level 1. The question isn't whether the climb is possible. The question is whether we survive the first step. If you want more videos like this, subscribe. Next time, we're covering the Great Filter, the invisible wall that might explain why the universe is silent.